Engineering and construction principles of ancient Indian temples. This is the subject of our discussion today. We often hear the proud achievements of the Indians in construction of marvelous temples with Vastu Shastra in its backdrop. The achievements of Indians look pale when compared to the antiquity, variety, and impressiveness of the Egyptian buildings. We should not forget that we do not find ancient buildings in India which are comparable in antiquity and grandeur to those of the Minoan, Mycenaean, Babylonian, Egyptian, Turkish, and other cultures. The basic concepts of the engineering behind ancient Indian temples is discussed here for the non-technical general public. Hundreds of serious studies have been done on the architectural and art of the Indian temples. But until now, a very few studies have been done on the structural system of these temples. For structural analysis of temples, the details of their plan, materials used, physical and mechanical properties of the materials, thickness of the walls, sizes of the columns and beams, stages of constructions are required. Most of the times, these details are hidden behind the decorative panels, sculptural carvings, icons of the various deities, humans and animals. Famous temples are declared as protected places by the law, and it will be very difficult to get the permission to collect the structural details of them. Entry into the Garbhagruha or the sacred sanctuarium is restricted to the priests, and at the same time these are at the darkest and the mysterious places for the general public. Some temples maintained by archaeological department are accessible to everybody. Even though layout or the plan of some famous temples are known, there are no structural details of them. With all this lack of proper details and data, it is possible to analyze and understand the engineering principles behind the construction of these temples. In India, the construction of a house, palace, or a temple was based on very basic and simple engineering principles. And for this, two major concepts can be recognized. First among them is the employment of the heavy structural members having very high sectional properties such as width, depth, and section modulus, etc. to carry out the loads coming on them. The second one is the employment of wide footings bases for stability such that the lines of forces pass through them without much eccentricity. Because of these principles, dry masonry dominated the construction. Composite construction was adopted for many buildings. This consisted of thick walls with coarse masonry in inner and outer faces, while the internal space filled with rammed brick, rubble and earth. The thickness of the walls varied from 0.3 meters, that is 1 feet, to 4.5 meters, that is 12 feet thickness. The average thickness of the walls in the superstructure was 1 meter, that is 3 to 3.5 feet. The size of the columns varied from 1.5 feet to 4 feet. The size of the beams were many times higher when compared to the load carried by them and their span. On this basis, 5 major techniques were adopted in Indian temples. First among them is the wide base compared to height. Second one is the large sized walls and columns. Third one is the corbelling for reducing the span. Fourth is the simple structure comprising of column, beam and slab. Fifth one is the symmetry in plan and elevation. In such a construction, all the major load carrying components will be in compression. The stone, brick have got very high strength in compression. These were the major construction materials for all temples and buildings. These have their own advantages which can be listed. First one is, no theory is required to understand the behavior of the structural system with these materials and construction techniques. Second one is the ease of adapting the materials without knowing their mechanical and physical properties. The third point is, no requirement of complicated mathematical calculations. The fourth one is adaptation of the local construction techniques and equipments. And final and the fifth one is, no special knowledge is required to achieve connection between the various structural members and components. With these simple principles, it is impossible to construct a building which can satisfy modern requirements. For example, it is not practical to construct an apartment or an office building of 10 floors with 6 by 6 feet size stone columns placed at 10 feet centers. From these ancient principles and techniques, it is impossible to achieve large open spaces without columns. The usable space in a building in ancient construction was very limited when compared to the modern buildings. The area occupied columns, walls, posts in plan of a building is designated as structural density. Increase in structural density indicates the reduction in usable space. In modern days, there is a great pressure on civil engineers to reduce the structural density to the minimum possible. The glimpses of structural density and usable area of the ancient temples can be seen from the tables shown here. The structural density of North Indian temples is in range of 30 to 70% at an average of 49.33%. The structural density of South Indian temples is in range of 15 to 60% at an average of 36.55%. The height of the temples, which was 6 to 8 meters in common era 5 to 6 centuries, increased to 20 to 25 meters in common era 10 to 12 centuries. The height increased with experience of construction. The average height of the North Indian temples is 15.79 meters, that is 5 to 20 meter range. The average height of the South Indian temples is 13 meters, that is 40 feet. The average area of South Indian temples at Garbhagriha, that is the sacred sanctuarium, is 37.32 square meters. When compared to the European buildings of same period, the height of the Indian temples is not so impressive. During this period in Europe, buildings up to 100 meters high were constructed. Qutub Minar in India reached 70 meters, but during the later centuries, the height of the temples is low when compared to all the other European constructions. From the structural density, it is clear that the Indian temples were built on simple principles of carrying loads by massive structural elements under simple behavior. In old churches of Europe, the structural density is in the range of 10 to 20%, where it is 5 to 8% for modern masonry structure. Structural density of modern RCC structure of 100 floors will be around 2 to 3%. If the same structures are constructed adopting the principles on which Indian temples are built, then there will be no useful space in the building. The structural density of pyramids is 99.9%. That means there is no usable space in it. This reflects the difference between the modern civil engineering and the traditional knowledge of construction. Temples and earthquake. Nowadays, some people are raising loud voices that if the techniques explained in the Vastu Shastra are adopted and footings are taken to a deep, the buildings can sustain earthquakes. The wide statements of these technical and unqualified people is creating momentary excitement among general public who are very proud of their own ancestors' achievements. The modern civil engineers who can design and build very complex skyscrapers have conducted some studies on the seismic behavior of the selected tall buildings already. Jagannatha temple at Puri, Odisha has been built using locally available chandelier sandstones by laying them in aster masonry. No mortar is used between the two courses of this masonry. Instead, the wrought iron clamps and pegs are used to keep the adjacent and core stones in position. The same technique has been adopted in temples of Karnataka also. Main temple and its tower is constructed in curvilinear form by corbelling to form the truncated pyramid. Due to this, all the courses are in compression. The main tower, that is the Gopura, is 66 meter high, that is 200 feet. The thickness of the walls at the base is 5.5 meters, that is 17 feet. The base width is reduced at 3 levels by corbelling techniques by deflecting the wall towards the center. At the final corbelling level, the span between the two walls is 9 meters, that is 27 feet approximately. Square pyramid wrought iron beams of 20 by 20 centimeter size of cross-sectional dimensions are used further to support the upper part of the Gopura. After completion of the tower, outer face is lime plastered in 3 layers to form total thickness of 45 centimeters. Inner face of the tower is plastered only to a height of 3 meters. Puri is in the earthquake zone 3 as per the Indian code of IS 1893, part 1. As per the currently available records, the maximum earthquake measuring 5 on Richter scale is recorded at 100 kilometers to the southeast of Puri. The buildings which have the full connection between their structural components responds more to those which have unconnected members. The towers like Jagannatha temple constructed on simple principles which comprises of stone units without connection between each of them are in complete compression and respond less to the earthquake. The tower of Jagannatha temple belongs to this class. The studies have been done on Jagannatha temple tower and found that it can sustain earthquakes up to scale of 5 on Richter scale. From civil engineering, it is well known that if the plan and elevation of a building are in symmetry and loads are uniform, then the center of gravity of loads and the centroid of base will be on the same vertical line. Such buildings, when subjected to earthquake forces, experience least torsional moments and more safe under the earthquakes. Keeping this as basis, some Vastu proponents are propagating that this was known to the ancient sages and seers. In olden days, only house, palace, temple structures existed. It was not possible at that time to construct buildings with multiple usable floors. The gopuras or towers sustained their own loads and did not carry any external loads due to human activities. There was no space for human activity also. The area was restricted, and at fourth or fifth story level of the gopuras, it accommodated only 8 to 10%. Their purpose was very limited. In modern times, variety of designs are demanded for different functionalities. The requirement of structures or buildings to support various equipments or machines, vehicular traffic, which change their load centers rapidly is norm in a modern day. These require non-symmetrical plans. Many times, even though plan is symmetrical, loads are non-symmetrical. Situations like these were beyond the imagination of the temple builders. To build a non-symmetrical building safely, the civil engineering depends on the knowledge founded on firm theory, supported by experiments. Since such knowledge was not available in ancient construction, it always adopted symmetrical planning. Civil engineering boldly proposes symmetrical planning wherever possible and feasible, and it defines such symmetry through specific calculations. At the same time, it takes the challenges of asymmetry graciously. In comparison, the principles of temple construction appear to be a child's play when compared to the modern civil engineering principles and construction techniques. Now, from the viewpoint of knowledge and technology, it is obsolete and shall be thrown out, and we should adopt only modern engineering. At the same time, Vastu Shastra also contains our iconography, traditional art, and cultural elements. So we can employ Vastu Shastra as an art form to construct heritage buildings, temples, etc., based on the modern civil engineering. Thanking you.